India and has long-standing research experience in radio communications. He received his PhD degree on radio wave propagation, studies of fixed and mobile communication over southern India from Sri Venkateswara University, Tirupati, India. Earlier, he worked at Aalborg University, Denmark, as a research professor at University Closet 3rd, Demerit, Spain, and at the University of Sydney, Australia, as a visiting professor. Professor Ramarao received significant funding from the DST Government of India to develop high-performance millimeter waves antennas at 60 GHz and associated transceiver circuit for gigabit wireless applications for Defense Research Development Organization (DRDO). He is also working on inter-satellite radio link investigations at millimeter waves with funding from Indian Space Research Organization (ISRO) and developing wearable antennas for wearable devices applications for DRDO also. Recently received funding from DST GOI under FIST program to develop photonic wireless communication. So it's a great pleasure to have you, sir, with us as an eminent speaker for this STTP. We'll wish for a good learning to all the participants. Over to you, sir.
Yeah, thank you, ma'am. I'm glad to give you for your institute via this FTTP. And today's topic is as the buzz is millimeter waves. So you hope you know, right? All RF spectrum, uh, we will tell conveniently. So sometimes we talk about the frequency hertz, and sometimes we say, okay, based on its wavelength. So because the velocity of c equal to n lambda, velocity of the light depends on n and the frequency and the lambda. So it is all interchangeable. So if you convert that frequency into wavelength, if it comes in millimeters, then it is called millimeter waves. So mostly we say it comes under, I will show you RF spectrum and everything, then you will get some idea. And I will talk about this radio spectrum and why we need millimeter waves and its characteristics, applications, and what type of standards available and everything I will tell you in this talk. So this slide shows, things. Say, for example, computer. Earlier, 60s and 70s, you would have heard mainframes and everything, and it occupies the room. From occupying big spaces to it came to desktop computers, and now at the palm size also. All we are using our electronic devices and chip level also now came into picture. So that's the way things are going at electronic side, whatever you name it, Moore's law and everything. On the other hand, if you look at it, communications, especially wireless communications, we started with the first generation sometime back in 70s and thing. And then we all know, we don't know about first generation communications, analog communications with low speed, low data rates and everything. But all we witnessed this 2G GSM communications around 90s and everything. Then 3G came. By 2000, 3G came into picture, and by 20 another 10 years back, we know that 4G started. By before 5-6 years, we know that 4G LTE, long-term evolution, long-term advanced versions and everything came up. And before that long-term, this 4G, we have 802.16d or 802.16m, this popularly known as WiMAX. It is also a good technology, and it with WebDM and everything. But this 4G, when LTE came up, it overshooted this WiMAX technology. Indeed, when I was in Sydney, Australia around 2006, I was using fixed wireless using this WiMAX technology only. Now, right, when GSM was there, I still remember when BSNL started, if you get a call, you have to come out of your home and you have to talk in an open space. From that to now, we are having our video calls via WhatsApp and everything. But still, we are facing issues getting connectivity and everything. But due to whatever the reasons surrounding regulatory bodies and everything, and in that scenario, now we are talking about fifth generation also. Indeed, this COVID stopped these penetration of 5G communications. On the other hand, there is a lot of buzz. Today also, we are now meeting with you people these communications only. Whatever you name it, whether this is a 4G technology or IP-based technology or something, this communications making us joining together. Because earlier just text-based and voice-based thing, now IP-based thing. If you know any geo platform, all we know that it is a IP-based thing, data-based. So how much data consumes matters a lot now. That's what now Geo Reliance, they say data is the new money or new mantra for the society. So how much you consume, it is now earlier we were looking at minutes, hours and everything, talk time and everything. Now how much data. So all your voice is also routed via this IP based networks. But of course, your signal or your data is modulated over RF signal, which is analog, and transmitted one point to another point via antennas and everything. So, but again, it will be demodulated, converted, and whatever way you wanted. So, though we say digital technologies and everything, we don't have 100% digital technologies. Especially radiating from one point to another via antennas is analog only. But that data is, yes, that is digital. We say 1 and 0. That's what I always say. Digital electronics means 1 and 0 only. So that whatever we are typing ABCD converted into 1 and 0, and we transmit from one place to another place. And this slide shows that the 5G penetration all over the world. You see that all blue color is already they started, and Europe and Americas and everything. And some like India is also Geo is planning. If we don't have this COVID, we would have got it 5G handsets and everything. Already some players started releasing 5G handsets, and some operators are also ready, but it may take some more time, and it's just a matter of time and everything. So what is 5G? So 5G is nothing but much better communication. So we are, as I told you, GSM, we were having message and voice based thing to IP based thing, and we are witnessing now megabits per second data rates, and we can call over WhatsApp and everything. Earlier, we have ISDN to call international phone calls. Now with the WhatsApp call, you can talk to any of your friend and everything with the voice and everything, or Skype you can go, whatever you name it. But of course, earlier also Skype was there, but it is now WhatsApp and some other technologies came up like Zoom now, and this GCR, Google Classroom and everything. And now much better now if you have a good connection and good connectivity and everything. So this can go with multi-hop communications, and especially device-to-device communications will come up, and ultra-reliable communications. Earlier we don't have. I told one example when we were having started 2G communication, we had to come out of the house, or you have to find a good clearance. Then now we are going to have dense deployments, vehicle to vehicle talk each other, massive machine communications, machines will talk each other, and industry is also. So wherever now you can go, you can have this connectivity, and you will get a better kind of thing. So it is supposed to have by 2020, but due to this pandemic, it may push some time. Maybe by next year we will get all these things into hand. So it's a 5G onwards. It's a, like a common platform. Up to 2G, 3G, even 4G. It's a, like a box type. If something goes wrong, it is difficult to repair, or unless from network side, it's a very difficult. But 5G onwards, it's a, they say sliced network. Even one part of network goes down, it's easy to repair. This is sliced network, and several things can say emergency hospital, vehicle to vehicle, and this commercial activities. You can configure whatever you wanted, and accordingly you can charge billing also. Even on, till now, we were having based your plans and everything, but based on services, things will come up that one. So, and cloud, we are going to use cloud and software defined network, virtualization, and of course we are looking at sustainability also, and taking care of this nature and everything with the secured connections. And this is the topic what I want to say. Yes, whatever we say, wireless or communications, digital or electronic communications, you need radio frequency. Otherwise, it's very difficult. Earlier, yes, whatever GSM works at 800, 900 megahertz. Then later we moved to 1.8 gigahertz, 2 gigahertz, 2.2. Now 4G is handling 2.2. So these are all handles, but it depends on that coverage. As long as you move to high frequency, your coverage will come down, but whereas capacity will increase. So that's why 4G is handling much better than our 2G communications. On the other hand, latency is like a delay. So this high frequency is very low latency we can expect. On the other hand, that low frequencies can get latency high. And keeping that, people are now going into say 24 gigahertz to 40 gigahertz, and people are introducing, because that wavelength comes under millimeter waves, so it is called as millimeter waves. But for the moment, that utilizing these millimeter waves called as standalone operations, it will take some more time come into picture. But for the moment, people are looking at non-standalone operations. That means like a cellular mode, which works at 3.5 gigahertz. So these non-standalone operations already started Europe and Americas and everything. And some countries, even they started this millimeter wave prototype versions, but we have to wait and see when it will come and everything. Because that handset is the important. So far, we don't have handset with millimeter waves, or it is all under test or prototype versions only. Later, I will show you why it is making delay and everything. So sometime back, IEEE told that communications, caching, and computing is the future, and this is the our content-centric mobile networks will come into picture. So that's what we are enjoying: content or data or virtual reality, augmented reality. We didn't even expect that we will see each other with video or whatever that thing. Now, certain applications will go virtual reality and augmented reality kind of thing. And this is the overview of radio wave spectrum. And it we can start with very low frequency to extremely high frequency. It's easy to remember: 3 to 30, 30 to 300, 300 to 3 gigahertz, like that. So low frequencies, that kilohertz and everything, that era gone, we are not using. But HF we are using, especially airlines and everything. Then VHF, we started using our FM radio. We know while driving and everything. All now, okay, even some websites are giving songs and everything. But even I use still say 100 megahertz or 91.9 megahertz frequency spectrum to get songs and everything, but we don't get video capability. But then above 300 megahertz onwards, we can get capability. I hope most of them have visited or at least seen our Tirumala Hills, where our Lord Balaji was there. So if you see Tirumala Hills, in one of the hills, Narayanagiri Hills, you can find a big tower which radiates 224 megahertz signals. Some of them, you know, right? Earlier we were enjoying Doordarshan, keeping our Yagi antennas on the top of our house and watching Chitralahari or some Ramayana, that serial and everything. So earlier that broadcast mode at 200, because that low frequency can cover a lot larger distances. So we are all getting but analog signals only. But now we have digital signals and it needs some lot of bandwidth. So we went to this uh, 2 gigahertz spectrum, 2.2, 1.8 and everything. And still 5G cases, 700 megahertz is also considered as another contender because it will travel longer distances. And of course we have some frequencies, satellite to satellite and everything. And you remember earlier we were having this C band communication, that cable TV. Now cable TV to now we came to D2H, direct to home. That direct to home uses around 12 gigahertz. That's why we have small sized dish antenna, and whenever rain or cloud comes, signals will be stopped. I will show you in another slide what is the effect of these things. And this is the thumb rule is, just to remember, 3 kilohertz to 30 kilohertz is a low frequency, very low frequency. 30 to 300 low frequency. 300 kilohertz to 3 megahertz is medium frequency. 3 megahertz to 30 megahertz HF frequency, like that. So, but some that when radar point of view or a military point of view, they use S band, L band, C band, KU band, Ka band, and all these things. So it's all convenient. We go these things. So we use several applications, broadcasting, one-to-one, we say full duplex systems, vehicular communications. So all these need, when you say wireless, you need radio frequency spectrum. And this is one, I like this figure, which shows range, bandwidth, antenna size, and with depending on low frequency to high frequency. When you have low frequency, you will get range, but you will get less bandwidth. And of course, antenna is a very big, high size is very high. On the other hand, when you go high frequency, you will get less antenna size, but of course you will get good bandwidth, but you don't get range. So, but people are looking at optimization between these areas so that they will get range, bandwidth, and all these things. But that era gone. I will show you later slides why we need millimeter waves and everything. Okay, by the way, some story was circulated that sometime back in Rome, one town called Ant Amnum. That Ant Amnum, having trees and everything, that trees, they were used as a poles over a ship. That ship, you know, they will tie up with threads and everything, right? That pole is called as antamnum, antenne. From antamnum, that city, town, ships were earlier, you know, ship was the mode of transport. So they kept these things and they were used these poles as antennas to tie that ship, and there our Marconi kept our antennas, that RF things. So that poles with antenna called as antennae and everything. Now antennas. Antenna is a British word and antennas is a US word. So this is the theory behind how we got it, antennas and range, bandwidth, these relations. And coming to millimeter waves, so I proudly show you this slide. He's Professor Jagadish Chandra Bose, who demonstrated 1897 an experiment at millimeter waves. That means at 60 gigahertz. At 60 gigahertz, if you convert it into, it comes under millimeter waves. So he carried out extensive experiments on tabletop, and he demonstrated at Royal Institute of London, and he got SAR and everything, but he couldn't go patent or commercializing the activity. So because at that time we were under British rule, but whereas Marconi demonstrated his wireless experiment transatlantic with voice related. So he went to patent and everything. So everybody thought that, okay, Marconi done and everything. But our JC Bose guy done lot of experiments with the 60 GHz with available technology at that time. You imagine 100 years back. Of course, Marconi also done. But our guy went ahead of that and showed 60 GHz experiment with available semiconductors and everything. So he should be called as actually father of wireless communications. Unfortunately, 2000 onwards only his contributions were recognized, but now slowly everybody quoting when 60 gigahertz means they will quote his experiment and some of his contributions. And 60 gigahertz again, why means some frequencies are licensed, some frequencies are unlicensed. Say our 2G, 3G, 4G signals are licensed things. That means it is given to some operators. So you have to pay for that one. Otherwise, you can use, say, our Wi-Fi signal. Wi-Fi signal is licensed, unlicensed free. So you can use anywhere, anytime, and everything. So then US started 57 to 64 gigahertz bandwidth is available. And Canada, Korea, so Japan, Europe, Australia is also came up, all those things, and India, of course, will follow US and Canada things. So if you have bandwidth, you can send any amount of data. So bandwidth decides our data rates and everything. So that's the reason. And later 70, 80 gigahertz also came. But when it comes to India, we have a problem with defense and everything. Yeah, and this is another figure how bandwidth is shown, 7 gigahertz entire bandwidth, and all these things. This is the thing, atmospheric attenuation versus frequency. Up to 10 gigahertz, we will get some protection from rain and everything. That's that when you have D2H, this our Airtel or Tata Sky, when we have clouds and everything, we will get that signal obstruction, because that frequency molecules are H2O, water vapor, hydrogen and oxygen molecules. When they come to these, close to these frequencies, the resonance effect will come up. We would have studied in high school that resonance makes uncomfortable or absorbs something, and then it will block that signals. But that's why another, sometimes people will go low frequencies, that coverage, and avoid this absorption by H2O and fog and clouds and everything. And this is a one frequency figure. At 60 gigahertz we have huge absorption, and around again 150 megahertz, 150 gigahertz also. So if you go millimeter waves, you will get less working range, but frequency reuse. So that means it is absorbed by oxygen, water vapor, means it cannot penetrate longer distances. So that is the gold mine, as we can't use longer distances something. So each room you can keep one transmitter receiver. So you can't get any interference, you don't get any issues and everything. So on the other hand, that antennas also, traditional antenna, if you go dish antenna, just 13 inches, then 130 inches when it is 6 gigahertz, and very narrow beam width will come at gigahertz. So low interference, these things will come that one. So when compared to this fixed and wide thing, we started with kilobits. Now we are aheading of gigabit data rates. So 5G and everything with these things are expected to get a large bandwidth. Another advantage with millimeter waves and everything, penetration. So it say like pine board, clay brick, this our plywood, glass, all will absorb 6.4 dB, 10 dB, and everything. And whereas at 2.5 gigahertz, it is very less than that, 1.5 dB and all that thing. And when atmosphere, it is 1.5 dB per 100 meters. Whereas there is no absorption, oxygen absorption at 2.5 gigahertz. So that's why we use this low frequencies at larger coverage and 60 gigahertz for shorter distances only. And another, sometimes people will get this a common point, this, we say fading and, we don't get a signal and everything. Normally, when a transmitter transmits signals, it will go via ceiling, walls, and everything. Then it will reach receiver along with direct ray. This red line is direct ray. If you have a direct ray, you will get a better signal. But this reflected signal sometimes dominates and will distract that direct ray. So if rays are in the same phase and the same angle, then you will get a constructive signal. But if it is, say, -1 is 30 degrees, another minus 30 degrees, like a phase difference and everything, they cancel each other, and finally you will get a destructive signal. That's why we call these are all multi-path. So if multi-path is having same angle and same values, then we will get constructive. But if it is cancel each other, we will get a destructive signal. So that's why sometimes corner we will get some good signal, but if you come in the middle of the room, you don't get a signal. So that's the problem with this kind of thing. So coming to this, we say wave propagation. Millimeter wave also comes under wave propagation. It is characterized or dominated by refraction, diffraction, multipath, scattering, and reflection. I'm not going into definitions. I hope you know all. When a wave falls from one medium to another medium, it will take other diffraction or refraction and everything based on that refractivity of the medium and everything. And of course, we will get Doppler effect, material penetration, rain and thing, and natural free space loss also. Because over this free space, it cannot propagate because the natural obstruction that will come. And of course, some these millimeter waves will get this foliage loss, this water vapor thing. And of course, atmospheric attenuation by H2O and O2. So this is basically that resonance effect. See, oxygen molecules will absorb these frequencies at a thing. So I just take 1 minute. Any doubts so far? All these things.
Why normally microwave frequency is called millimeter wave, sir?
Madam, sorry.
It's okay, sir.
Yeah. Now we can go continue again. And I hope I'm very clear about giving details. And okay, now this is the behind why we need all these things. Advantages is bandwidth, and we can go applications. What is this building to building and printer connections, and like this meeting and everything, we can go sharing information and everything. And this is another millimeter waves home environment. All, if you have just one connection, that with that you can watch TV, phone, and everything, some entertainment and everything. Just 1 millimeter wave transceiver is needed. And this is another application of this thing with fast downloads, public hotspots, bus, trains. Like earlier we were using, you remember, CDs and pen drives. CDs now gone. Now pen drives we are also using. That also will go. Now we have that semiconductor based chips, right? Even our iPhone, the Mac laptop and everything. So these quick downloads, you will get it, and very faster way you can go. And if you go restaurant and everything, we will get caves, we can download and all these things. And the biggest thing is this vehicular communications, this radar, the 77 gigahertz, the high-end BMW and these our Mercedes-Benz and BMW, they are already having this millimeter wave radar. But in India, especially, we have restrictions with defense. So that option is not yet available so far. But even drones also coming with the radar at millimeter waves. Another is this vehicle to vehicle, this driving assistance and other things. This vehicle convoy, something coming, any say cylinder vehicle, gas station, and all these things will come into, you will get alert. Or if something accident happened, then you will come to know that alert quickly that somewhere it is happened, don't go there, you take another route like that. Or CM or PM convoy is coming, then you will get these alerts. So that's the advantage with these vehicular radars and everything. And broadcast transmission system, all this we know, right? Earlier, even cricket match and everything, or any live telecast, they will come with a van and with a big antenna and everything. So just millimeter wave transducer, I will show you that camera size also. So you can keep one HD camera with a millimeter wave, then you can transmit from that match point to, and we can get closer view and even three-dimensional or virtual reality and everything. And this is another good, this satellite to satellite. Now people are talking about high altitude platform services, especially Japan and everything they are considering because of earthquake zones. So they get, if they keep our communication system on the space, energy not an issue, they will get from solar and no disturbance from the ground, these earthquakes and everything. And now even airplanes, we are now allowed to get Wi-Fi also. And tomorrow we are now going to Moon and Mars. This satellite to satellite communications will increase, and space, as there is no absorption, as it is a vacuum, you will get much better things in space. And of course, imaging, like our CT scan and everything, you will get millimeter wave imaging. You can diagnose medical, so many medical things are there. And this is one classical example. If you keep some objectionable material, it will detect that one. And this guy is having some pistol. So I hope you all know that when you go for airport or something, they will do, nowadays they are doing manual frisking. But if you keep these wireless things, detectors, while entering at the parking area, or it will be detected and it will give alert to security agencies. The moment you come to main gate, then they can tell you have something. Instead of taking it to inside and with manual frisking and everything, you can detect whatever that thing, explosives, gold, whatever material and everything. And that's the advantage. And this pacemaker, these wireless pills and everything, also you will get these things. Now I need not to tell advantages of having miniaturized circuits and everything. And this is the data center networking. So many cables and everything are there. If you go your IT backbone center, so these we can remove with these wireless transceivers, so that data can be transferred from one system to another system. And of course, optical is also coming. Defense people are using optical things, and we can use, because millimeter, next is optical spectrum will come. So this also possible. And military, these the people are expecting a lot. Military applications, combat, secure communications, reconfigurable software-defined systems, and ship and everything will come into picture. And it is not that, okay, 60 gigahertz coming, we have to throw it away. No, we can use that existing Wi-Fi 2.4 or 5 gigahertz also. So it will work like all-in-one solutions also. And this is the new scenarios implementing millimeter waves. This drone communications, especially it will increase in coming or futuristic way, and vehicle-to-vehicle communications, and this virtual reality, gaming, and these things will come up with these things, whether home entertainment or commercial entertainment, and commercial drone activities and everything. I don't know, you have seen one news, one hexa, just a man can sit and he can go in the space via drone also. That is also coming up. People are expecting by 2035, drones can take humans also. So with just a simple technology and everything. Yeah, okay, coming to this technology, this is the transceiver of any communication system. So we will get a low noise amplifier, then modulation, demodulation, this analog to digital conversion, then baseband processing or signal processing, then again digital to analog, then modulation, demodulation. So all the LAN amplifier and all this. So whether iPhone or some other low priced phone, this is the thing we have. Right now, up to 4G phones, it will consume 120 milliwatts. Or if you take 2.4 gigahertz transceiver, it consumes 120 milliwatt of power. Whereas this millimeter waves will consume 2-watt power. That is the biggest problem with this. So you imagine now when if these are all again typical values. If you start browsing, getting data and everything, how much power it is needed. So then we don't have that lithium-ion batteries cannot provide that much on our now so far handset, unless we go that 2000 or 20,000 mAh batteries and everything. But then again it will down, that battery will goes down. So this is the one issue people are waiting to solve, this battery and power problems. So just taking this comedy from a cartoon. Anything so far, you have any doubts and everything? So please don't hesitate to tell me. Yeah. Then okay. Now who is telling why milliwatt? Who is deciding OFDM? What is the modulation? Why this antenna? So that is called as standards. So 60 gigahertz standards. When we say that IEEE will come, 802.15.3c was the oldest one. They have given some specifications. Then wireless HD, YGIG, then European Commission also came into picture, then 802.11 AD. So like that, they are all given, and they agreed that coverage will be less than 10 meters at 60 gigahertz. And uncompressed high definition television video or uncompressed videos. So far all the videos and everything, it is compressed and send it over. Even all our video audio is compressed thing, except audio. But videos are compressed one. But with millimeter waves, you will get uncompressed solutions, and you will get 1 gigabit per second data rates and everything. So these people all over the world, they will form group, they will do some experiments, and they will calculate that delay spread and RMS values and received signal strength. Based on that, they will calculate and they will recommend. And this YGIG, this is one another standard by a private company. I think 2017-18 itself, they said they will get to 2.4, 5 gigahertz and 60 gigahertz transceiver will come for desktop or laptop computers and everything. But I didn't see any, maybe prototype is available or something. And we use same BPSK, PPSK form, but we go that 64, maybe 256 form and everything. But again, you need high signal processing and everything. These are the another applications, point to point, your screen. Now all screen also we are doing with cables, right? That will be avoided when it comes to these things. And these are the trial installations. These photos, some 10 years old thing from United States. They have done, especially Bell Labs and other things, Sprint. They are all the service providers. Coming to this side, Japan is also good in this, getting these devices, Sharp, NEC, and everything. And I worked with this Millimetre, South Korea. You see the size of the paper clip and the size of the transceiver. In one of my DRDO project, we made a custom-made transceiver, because the 60 GHz testing signals we don't have facility. We need a 60 GHz spectrum analyzer. So I was having 3 GHz spectrum analyzer only. So then I down converted to 3 GHz, and we made some experiment with designed antennas and everything. And these are the 60 GHz products. I told you, right? This broadcasting cameras and everything, you will get it, these things. And these are again some of the photos of the these things. And this is another band, Japan. They have done output power of 100 milliwatts with 20 dB gain and 10 milliwatt power. Depending on that, we can go. This is the one pen showing that one. And FM continuous wave radar is also there. Then coming to all, we know that SMA connectors, BNC connectors, coaxial connectors and everything. And when it comes to 60 GHz, connectors also play a major role. You need gold coated connectors. Sometimes you need to put from waveguide to this microstrip line or something. So it's not that much easy, and size is very less also. Okay, then when in a circuit we solder that one, an integrated circuit and everything. But when you test and everything, certain things you need connectors. So this is one another biggest issue. But earlier we did went SMA connector only, because we don't have this 1.85 mm connector. But then later we went custom made, done, and all these things. Okay, I give summary of these millimeter wave technology. So millimeter wave technology, you can use point to point, building to building, and you can go backhaul, fronthaul, and you can take signal passing radars, wireless LANs, satellite, sensor networks, and everything, signal processing, and you can go indoor, outdoor. The people worked, I think all you know, right? Rappaport, wireless communications by Rappaport. So he released a book on these millimeter waves. So it came in 2018 and discusses all these things, points. So at one shot you will get this picture, right? Anybody writing an exam and everything, if you see this one, you will get idea of this thing. This is the what I told you, right? This custom made transceivers did for my DRDO funded project. We made horn antennas, custom made again. And this is the thing, we made a down converter to 3 GHz, because output will come at 60 GHz from horn antenna, from a waveguide port. So we made custom made, and of course some losses will come. We showed into simulations and everything to compensate and everything. And these are the another way I went this PCB or FR, not FR4, Rogers based patch antennas with the SMA connectors and everything. You see, at that time I did around 10 years back these coin, 10 rupee coin. At that time they were released. So this is the size we did. We say corrugation. I went all with corrugation, without corrugation, and everything. So antenna, you know, is a very beauty. You can do based on shape, size, whatever, you know, configurations you can go. you can achieve better performance. And this is my last but one slide. Bugs. Really, our nature provided a very wonderful, activities. Each bug will do its own action and everything. I see these, I can say it's not wings. These are the antennas for these bugs. Yeah, with these antennas, it will smell, it will identify, it will swallow honey. If you put sugar, ants will come and take away and all these things. And you see these antennas in very good shape also. So I think that's why it does its own action based on its shape and these things. So I want to, tell even the researchers and everything, inspired from the nature, how these things will do, and try to mimic that one in our actions, so that we can get better solutions and everything. Another this slide, I like to show, everybody feels that ones and zeros, data, digital communications and everything. And they say, this cartoon says wireless data pollution. Normally, yes, ones and zeros plays major role for converting our ABCD or whatever language. But when antenna to antenna, it is that RF wave will carry these data, not just like that what it is showing and everything. So we have a wonderful future ahead of with these technologies. People say again, how about RF waves will get brain tumor or something? In my sense, I'm using for the past 25 years, and sometimes we go with 1 watt power also. But you have to use in a proper way. Say, as we told, right, H2O will absorb millimeter waves. So it will stop at your skin level only. So it won't go into inside, because again, okay, you have blood and everything. Blood will circulate your 24 hours and it regenerative. Even some blood cells will die, but other blood cells will be recreated immediately or after some time. So it doesn't, but the only thing is cautious is you shouldn't hook 24 hours these wireless technologies, because whatever, say sugar is very sweet. We can take 1 spoon, 2 spoon, 3 spoons, but we can't take 5, 6 spoons, right? Or we can't take half kilo sugar at a time. So excess is always dangerous. With this, I want to say that enjoy with wireless technologies, and especially millimeter waves. There is no harm at all. Even some people say, corona is coming via these wireless technologies or something. These are all just rumors spreading to stop these 5G technologies or something. And man is going to enjoy these technologies in a big way. It's all just how we do or how we, look at into for better mankind thing. I'm allowed to tell if you have any doubts related to this technology or something. Yeah, I see some giving what is the difference between ultra-wideband 5G sub-6 gigahertz bands. Okay, ultra-wideband is 3 to 10 gigahertz. And ultra-wideband, again, the definition says it should have a minimum of 500 megahertz bandwidth. So when you have 500 megahertz bandwidth, then only it is called ultra-wideband. That is also used for just 10 meters radius range only, milliwatt power only. But it can, right now, wireless, our keypad, wireless mouse, they are using thing. And sub-6 gigahertz, that's what for the moment, non-standalone they are using, up to 3 gigahertz, 3. In India, planned 3.4, 3.5, 3.6 gigahertz for 5G technologies. That is called as sub-6 gigahertz. That means below 6 gigahertz, which is having protection from water, oxygen and everything. That's why they prefer. But the problem is bandwidth available. So, but on the other hand, delay spread and everything will come if you have huge bandwidth and everything. Another ultra wideband, it is a pulse based signals. It is not continuous waves signals. So all these they made standards and everything available. I hope Nagalashmi can getting that what I am trying to say. Which frequency band Divakar is asking? That's what. For the moment, 57 to 64. That US is allowed under license free. So that is maybe India is also will follow same thing. I will try to share this PPT, but don't more or less this content is available several times, and even my papers are there, or quote Rappaport book also. Another, since the frequency is high, radiation will be more radiation. That's what I don't see. That's why even our Indian government say, we say specific absorption ratio, SAR values. Internationally, it is allowed 2.0 watts per kg, whereas India following 1.6 watts per kg. So all our asked base stations to reduce the power also. So we don't get much. I don't think that is a big issue unless that's what. Another I always say, see, okay, leave that our mobile phones and everything. We are living in polluted area. We are dying. We don't know whether we are smoking, non-smoking, alcohol, non-alcohol. If you are living in industrial area, that might be causing so many health issues, right? So we can't pinpoint just a mobile phone that causing harm. No, it is. I don't agree as an RF guy. It might be several factors. Now during COVID, you would have seen, right? Boats are flying freely. Some animals coming on the roads and everything, where there is no activity of human activity. Human makes a lot of noise and makes a lot of uncomfortable to nature. So I blame it on the man activities rather than this radiation and everything. These are all, if you use in safe levels. That's what you can't. Sugar is sweet, but you can't take a half kilo sugar, right? The same way, we can't hook on 24 hours with mobile phone. That our screen, now everybody having smart screen. So that radiation will may cause our retina or our eyes, or we may get some headache or something. Yeah, thank you. Some guys, they say good information. So that's the reason. So give regards to our J.C. Bose sir also. So he was the inventor of these millimeter wave communications. So be proud that Indians are also part of developing wireless communications, but we didn't get our recognition and everything. So anybody having further?
Yeah, any more queries from the participant sides? So I think, sir, all doubts are clear of all participants. The session was really very much informative. Thank you so much, sir, for the knowledge, but what you have shared with us. Thank you so much, sir.
Thank you for giving opportunity for all sharing my knowledge with all you people. Thank you.
Yeah, okay.
Thank you,
dear
everyone.
participants, we'll meet again at 2 p.m. for the last session of today.
Ma'am, Payal ma'am.
Yes, ma'am.
I request that all participants switch on your camera for a group photograph. Actually, we send this group photograph to AICT, na?
Yes, ma'am. So really, I forgot.
Pallavi,
it is requested to all the participants. All of you just switch on your cameras for a group photograph. We will share all the attendance and photographs to the AICT. Yeah, thank you so much. Dear all, please don't bother about the study material or the PPTs shared by the speakers. After completion of this STTP, we will share all the information of all eminent speakers via mail to all of you. Okay, thank you so much.
Thank you.